Quick warning, I'm really bad in holding microphones, so if I start to do this, just warn me that you're not hearing me clearly and I will try to put the mic back up. So let's have a look at modern authentication. First off, my name is Bellen. I'm from Belgium and I'm a developer evangelist at Auth0. Anybody heard of Auth0 before? Few people? For those of you who haven't heard of Auth0, we're basically an identity as a service provider, which means that we try to make it as easy as possible for anybody to implement a secure authentication flow in any app or service. That's what we do. And you can find me on the internet as Sambeo, almost any website, Sambeo. So, authentication used to be easy. Not really, but it used to be a bit more straightforward than it is these days. Let's have an example, like you request a web page. What you would have was you had a browser and you had a server, and that browser would just say to the server, "Hey server, I want this page," and the server would say, "Here's your page. Go ahead and display this." Now, if you would want to authenticate on a website, you would do something like this. You have a browser. It would send the username and password to that server, and that server would start to check the username and password against the database or something like this. And when it found that this data is valid, it would just send a session cookie to the browser, and this cookie would prove that there's a valid session going on. And the next time you would want to request a web page for which you need to be authenticated, you just pass along that session cookie, and you get your HTML back. It used to be as simple as this. Of course, there's a lot of gotchas and other nasty stuff that can happen, but the basics used to be as simple as this. Modern authentication it's a bit more complex. So there's a lot of things going on with modern authentication. Grant types, Auth Flows, platforms. There's a lot of different types of authentication, and we're going to see 4 types of them. The first one is authentication from web apps. These are web apps on just standard old-school websites, not single-page applications. Web applications which are created on a server. So that's one. Next one is APIs. Single-page applications, because they behave a bit differently than the regular web apps. And native apps, desktop apps, mobile apps, anything like this. They all do authentication a little bit different, so we're going to see how to handle them in all of these instances. And we're going to see how to do this with Auth 2.0. Anybody heard of Auth? I think almost everybody has heard of Auth. This is Oauth, an open standard for access delegation, commonly used as a way for internet users to grant websites or applications access to information in other websites, but without giving them passwords. And this is what's important. It's an open standard for access delegation, which means it helps us delegate access to protected resources or protected pages. And it's really good at that. And there's a few roles when working with Oauth. The first one is the resource owner, the entity that can grant access to a protected resource. Typically, this is the end user. This is the user, you, me, the user who visits your website, the user who uses your mobile app, your desktop app. Second, it's the resource server. It's the server hosting the protected resource. This is your API, your backend. This is a server which builds your web pages or serves your data to your mobile app or your single-page app. The third one is your client, your mobile app, your single-page app, your web app, whatever you want. And lastly, we have the authorization server, the server that authenticates the resource owner and issues tokens. So basically, this is the server that's going to decide if a user is authenticated and which content it can view or which actions it can take. All right. Next up, Auth 2.0 endpoints. There's 2. The first one is an authorization endpoint. It's used to interact with the resource owner to get authorization and to access a protected resource. Basically, when you start to do the authorization process, you're going to hit up this endpoint and you'll get a code back. And using this code, you can access tokens. And this can be an access token or a refresh token. We'll see what these are in a minute, but you can get them from this endpoint, and it's not used in the implicit flow, which we'll also see in a minute. So an authorization code via an access token, via a refresh token, via an ID token. These are all kind of similar things. They don't do the same thing, but they're all just a string of text or a token or something you use to do something. So what's an authorization code? An opaque string meant to be exchanged with an access token at a token endpoint. So you're going to hit up your authorization endpoint, you get back, or you prove your identity, and you get back in authorization code. Then you're going to exchange that code for a token at the token endpoint. An access token is an opaque string or JSON Web Token that denotes who has authorized which permissions to which application. Basically, this token is going to tell your application or your API or your backend, this user is authenticated and it has the rights to do this action, to see this content, to do this thing. So that's what you use an access token for. The next one is the refresh token. Access tokens usually are, they don't last very long. They are limited in time at which you can use them. So if they expire, you can use a refresh token to get a new access token. And an ID token, they're not really part of the Auth spec. They're part of the OpenID Connect spec. But OpenID Connect is just a layer on top of Auth, which adds ID tokens. And ID tokens, they contain a bit of data about the authenticated user, their email address, their username, whatever is important to you. And these are always a JSON Web Token. So the Auth spec does not specify in which format a token should be created. This can be a string, this can be a JSON Web Token, doesn't really matter. The OpenID spec, though, it specifies that it has to be a JSON Web Token. Let's look at a few of the Auth flows. You have the authorization code flow, the authorization code with proof key for code exchange PKC flow, the implicit flow, and the client credentials flow. So let's look at traditional web apps. These are the web apps which are generated on the server. The server just returns HTML. All the logic is in the backend. It's done on the server. Authorization is also done on the server. And this one uses the authorization code flow. So the baseline. You have a browser and you have a server. And when you want to display a web page, you ask the server, hey, can I get a web page? And the server gives you HTML. Simple as this. The authentication, we have a separate authorization server here, but it happens a bit like this. Your browser will send the credentials to that authorization server. That server is going to check if these are correct. If so, it will give you a callback code, which is an authorization code. And then you use that code. You send that to your server, which is then going to post that to your authorization server, that code you got back, and it will get back your tokens, your access token, or your ID token, or whatever you want. And then it will create a cookie, a session cookie, and send this back to the browser. So when you're authenticated, you're just going to send the browser to your server, and it knows that you have a valid session, so it will return any data you want. Simple as this. When the user changes, you send that cookie, you send the changed password or user or whatever to the authorization servers together with that access token, which you got back in the previous step, and it will just give you an OK. And then you can say, yay, we changed our user or whatever. The second one is how to do authentication with APIs or backends using the client credential grant flow. And it basically goes like this. You have one API, you have a second API, it sends some JSON to the other one, it responds OK, or it returns some JSON. Straightforward. But when you need some authentication going on, you use your authorization server again. So you send a client ID and client secret usually to that server. It gives you back an access token. And then when you want to request some data, you just send along that access token together with your request. This can be done because these servers have these client ID and client secrets stored safely. You cannot do this in a browser, but if you have two servers and they don't get hacked, which we all assume does not happen, they can store these credentials, like the secret and the ID, safely. And then you return some JSON. You can also request refresh tokens. I mentioned them before. They're just to request a new access token when yours is expired. And you just pass along your key, your secret and your ID again, and you get a refresh token and an access token if you want them. And then if you want a new access token, you pass along your refresh token to your authorization server, and it gives you a new access token. That's all quite straightforward. And then, of course, you can use your access token, your new access token, to communicate with your other API or server or backend, whatever you want. And you get a response. The third one is a single-page application. And it uses the implicit grant flow in this example. You might have heard there's some issues going on with the implicit grant flow. I'll talk a bit about that later. For means of demonstration, let's talk about the implicit grant flow because it's an often used flow, especially with single-page applications these days. So, baseline, again, single-page application wants to ask some data from an API. It sends a request, and the API returns a JSON. That's how it works. But when you need to authenticate, you just ask your authorization server, hey, here is a user, password, whatever you want. Give me some tokens, and it will return you an access token and an ID token, which you then can use to request some data from your API. You just send along the access token. So we didn't have the step we had with the authentication flow code, that we first ask a code, get a code back, send it to our server or API, and then the API is going to request the tokens. We're going to request the tokens straight from the authorization server. And then we get some JSON back. And there's also a thing called silent authentication, which you can do with the implicit flow, because you don't want your user to log in every time it visits your single-page application, but you don't really want to save these tokens in the front end, because that's local storage or a cookie or IndexedDB in a web browser. They can all be accessed by JavaScript, and you don't want your tokens to be stolen. So to do this, basically, we're going to send our credentials to our authentication server. It's going to create a session and store a cookie for that, and send you your tokens, which you can use and store them in memory, but don't store them somewhere persistently. And then you use those tokens for the remainder of your whatever you're doing. But the next time the user visits, it doesn't want to authenticate again because it did this before, and you don't want to enter your credentials again and again and again. It's annoying. So you do a silent request in an iframe, and you just request the new tokens, but because this cookie has been set from this domain and is saved in the browser, the cookie should actually be at the bottom right, it can just send you your tokens because it knows that because of this cookie you have been able to authenticate before, so it's a valid session cookie. And then you can use your tokens to access or to request the data you want or do the actions you want to do. And you get back JSON. But note that the IETF, the Internet Engineering Task Force, is not recommended the use of this implicit flow anymore. Since a month or two, there has been a few papers written to not use this flow anymore because there's some security vulnerabilities which can cause attackers to steal your tokens, and you don't want that. So yesterday night, I think, they finalized their recommendation to not use this if you don't need to, but they don't say to just start changing all your applications now. If you just consider the security risks, you're still okay, but just for future applications, try not to use this one. There's a whole working group going on, trying to figure out how to do it more securely. They're going to start writing a paper about this. There's no real guidelines yet, except that try to do it as safe as possible. So yeah, that's something you should know about the implicit flow. And the last one is native mobile desktop, which uses the authorization code with the PKC grant flow, which looks a bit like this. Your mobile app wants data, you give it data, same as any other flow. But when you want to authenticate, your app is going to send a code challenge, which is usually a hash of a secret stored inside the app, to your authorization server, and gives back a code. Then you send that code together with your secret again to the authorization server. And if all of this matches and it determines that it's you who initiated the flow, it will send back tokens, and you can use those tokens to get data from your API. This is a bit more secure, but you need to be able to store your secret and your ID, especially your secret, somewhere safely. A mobile app can do this, a server can do this, a web app cannot really do this, so you cannot use this flow with single-page applications, but we're working on a way to kind of do something like this because it's the most secure flow. And you get back data. So in summary, modern authentication is complex because there's a lot of flows, there's a lot of roles, there's grants and stuff, so you have to kind of know which flow fits in which scenario. And if you know this, you can kind of just implement it in a safe and secure way, and as you're using the implicit flow, then you have to check some other stuff or not use it anymore. Auth 2 offers solutions, flows for most use cases. Like I said, it doesn't mean that I just showed a use case with a certain flow that you cannot use another flow, but these are some common patterns to use. There's a bunch of platforms like web apps, API, single page, and native apps. So try to use the best flow possible for your project. And implementing Auth 2 can provide a competitive advantage because it's based on standards. There's a lot of smart people who think about these standards. When there's issues coming, when there's issues being found with these standards, like the implicit flow, they try to figure out a better way to implement authentication based on these standards. Here's a bunch of resources if you're interested in Auth 2. Thank you. Are there questions? Yeah.
You talked a lot about the client and the authorization server, but you talk a lot about the resource server. Can you elaborate more on how does it work when the sign is requested?
Yeah, so you send your access tokens usually to your resource server, and usually there's some middleware going on which checks those tokens if they're valid or not, and if they're valid, it shows you the data. But it doesn't really have to go and through the process of checking your username and password or whatever authentication method you use, because it can validate those tokens.
So in the validation happens like some information from the authorization server to validate?
Well, there's a bunch of different ways that you can do this. If you use something like JSON Web Tokens, they contain a bunch of data inside of them and they're signed. So if you have a shared secret or a shared public key and private key between the authorization server and the resource server, they can validate that this is a signed, still valid access token, and they don't really need to contact the authorization server. Other implementations require you to still check that code at the authorization server. So it depends on your implementation. Any other questions? Let's get lunch then.